So we are going to solve a question based on preemptive SJF, which is also called as shortest remaining time first. The question is given with the processes along with the burst time. We have to find out average waiting time and average turnaround time. So what we are going to do, first of all, we will draw the Gantt chart. And here in this question, arrival time is also given. So suppose the arrival time is 1, 2 and 3. So now what we have to go calculate for this type of question. This much will be your question: process burst time, arrival time. So what we have to do for finding the average waiting time, we are going to add one more column which is called as the waiting time with the formula start time minus arrival time. Plus we will add one more column which is called as the turnaround time, having the formula waiting time plus burst time. So now with the help of this we are going to find out the average waiting time and average turnaround time. For that we will draw the Gantt chart. So as this is preemptive one, so in this case we are going to consider the time slot one by one. So we will start with P0. We are going to give P0. What was the arrival time of P0 is 1. So P0 was the first one to enter the queue and there was no process waiting for the CPU. So P0 will be allocated to CPU. So here what we will calculate, what is the arrival time and what is the start time. P1 has started at 1, so the start time will be 1 with the arrival time as 1. So start time is 1, arrival time is 1. So 1 minus 1 will be 0 for the first term. Now we will give P0 only for the first unit of time. Now the remaining time after giving one slot for P0 will be 9. Now at 2 millisecond, for example, who has entered the queue, the P1 has entered the queue. After P1 has entered the queue, to compare the P0 burst time along with the P1 burst time. So P1 is having lesser burst time than P0 as we are going for SGF. So the chance will be given P1 for the execution. So what was the arrival time for P1 is 2 and what was the start time for P1 is also 2. So the start time minus arrival time is 2 minus 2. Now for only one slot of time the P1 will be executed because we are going for preemptive 1. So this will be 3. Okay. Now after giving P1 for the first millisecond, what will be the remaining burst time is 3. Now here P1 at third millisecond a new process has entered into the queue which is having the time slot similar to P1. So in this case where P1 and P2 are having the same burst time, so what we are going to do, whose chance will be given to enter the queue will be the P1 only because the P1 has entered the queue first. So whenever we are having two processes having the burst time same at that time we will run, we can consider this as a FCFS. Whoever has entered the queue first will given the chance first. So P1 has entered the queue first, so it will be given the chance. As P1 is already in the queue, in the processing, so no need to calculate again this one. We are going to continue now. So no need to calculate this time slot, no need to calculate a waiting time because P1 is already given the chance and the same one we are going to continue. We are not jumping, we are not moving to some other process. That's why no need to calculate waiting time again for P1. So we are going to continue with P1. So for how many times slot P1 will continue? For P1 will be continue. This is the end of your question. No other process is going to enter in your queue. So what we are going to do, we can give P1 for the full remaining time slot. So P1 will be given for the full remaining time slot which is 3. So 3 plus 3, so it will be executed for 6 milliseconds. After then whose charge will be it is, so this P1 is now fully completed. Now we are having only P2 and P0 and the arrival time is already considered. So now this your preemptive SGF is converted into non-preemptive one, in which once the process is given for the execution it cannot be preempted. So now this is SGF, so P2 will be executed. So P2 will be executed for how many milliseconds? P2 will be executed for 3 milliseconds. So 6 plus 3 will be 9. Now we have to calculate the start time. At what time P2 has started? P2 has started as 6 and what the arrival time is 3. Now whose chance it is to give Now the P1 has given, P2 has given a chance, it is fully completed. Now the chance will be given to P0. Now this is the second chance of P0. So now we have to add the waiting time for the second term. So this, the current position will be considered as the start time. The start time and the previous turnaround time will be considered as the arrival time. So this was current position is 9 and the previous turnaround time of the same process, which is P0, is 2. So 9 minus 2 will be the waiting time for P0. Now P0 will be given the chance for the remaining slot, that is 9. So 9 plus 9 will be 18. So this is the completion of all the process. Now the time to calculate the waiting time. 1 minus 1 will be 0. 9 minus 2 will be 7. 2 minus 2 will be 0. 6 minus 3 will be 3. So these are the waiting time. So the average waiting time will be what? 7 plus 0 plus 3 divided by 3. So 7 plus 0 plus 3 divided by 3 will be your average waiting time, which is 10 divided by 3. And now the turnaround time is waiting time. Waiting time of P0 is now 7. The burst time was 10. So it will be 17. For the P1, waiting time was 0. 0 plus the burst time was 4. So it will be 4. Now for P2, what was the waiting time is 3. 3 plus what was the burst time is 3, that is 6. So the addition of all these things, that is 17 plus 4 plus 6, so divided by 3 will be your average turnaround time.